Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight podcast. I'm your host, Eric Walenza, CEO of IoT One, the consultancy that helps companies create value from data to accelerate growth. And our guest today is Tim Wagner, co-founder and CEO of Vendia. Vendia is a real-time data infrastructure provider that enables companies to securely share data across organizations and clouds. In this talk, we discuss the use of next-generation blockchain and serverless infrastructure to solve data sharing challenges related to security, privacy, and management. We also explored the three-body problem, or how conventional IT, private ledgers, and public blockchains can work together to usher in the Web 3.0 era. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, you can email us at team@iot1.com. Finally, if you have an IoT research, strategy, or training initiative that you'd like to discuss, you can email me directly at erik.walenza@iot1.com. Thank you. Tim, thank you so much for joining us on the podcast today.
My pleasure. Thank you so much for the invitation.
So, Tim, I've got to tell you, on this topic of blockchain, I guess you could define me as maybe a skeptical optimist in that, there seems to be something
you're in good
really
company there.
Well, there's something really interesting here, and obviously there's people like you that, based on your background, right? You've got the PhD from Berkeley, you've got the in computer science BSc from Princeton in computer science. You've worked with a slew of kind of market leaders in different areas, in technical positions. So you could be kind of spending your time doing anything that you wanted, more or less. And you've chosen this, right? So I think it's also interesting that a lot of really smart, talented people have chosen to devote themselves to this. And that also gives me optimism that there's really something tangible here. But of course, there's also a lot of speculation, and that creates a lot of noise around kind of quick money and so forth. So maybe just as a starter, I'd be really interested in understanding what is it, high level about the vision for what this technology can provide that has convinced you to devote, some significant number of years of your life to this, this domain.
No, it's a great question, and maybe kind of a natural segue too into sort of why I'm interested in this, why the company, why do a startup in this space and so forth. When obviously so many other things are happening out there. I'll give you just a little bit of the origin story here. So I spent about 6 years at AWS, started what's now known as the serverless division there. Of course, we didn't have that fancy word back in the day. What we did realize, and kind of what I went through to do in a sense was help democratize using the cloud. If you think about building an application from scratch using sort of the lowest level infrastructure in the cloud, it's a heavy lift, right? And not everybody who knows how to code or who has a kind of an IT team is necessarily up for the challenge of figuring out scalability and fault tolerance and kind of multi-region deployments and and kind of on and on and on. And so part of building what became eventually AWS Lambda and API Gateway and these other services was this idea of kind of making them so you didn't have to know all those details. You could get value out of the cloud and build some of those technical capabilities and applications and outcomes without necessarily having to deploy your own and manage your own servers there. So was very interested in that. Left AWS to go down to Coinbase, which was, and if you want to kind of continue the theme there, kind of democratizing access to crypto. You're making it so anybody can kind of buy, sell, trade in cryptocurrencies. One of the interesting things about working there was I got this fantastic ringside seat to this really interesting technology of distributed ledgers in the form of cryptocurrencies. And as you mentioned, they work well for speculation, right? And you can go to log into Coinbase or Binance or pick your favorite kind of brokerage out there, go buy yourself some Bitcoin, buy Ethereum. So they work as these kind of stock markets for this particular form of currencies. What they don't work so well at, and here's where we kind of get to the interesting kind of blending of these two pieces of the background. What they don't work so well at is functioning as an enterprise piece of infrastructure. And by that, I mean like trying to use, for example, Ethereum as if it were a database that two or more people could use to share business data. And when I say it doesn't work well, I mean that in a kind of, both sort of a qualitative way and also in sort of a quantitative way. Like Ethereum can do about 14 transactions a second. Your typical bank or insurance company or whatever is doing tens of thousands, maybe hundreds of thousands of transactions a second in their various mission critical applications. That's a lot of zeros that are missing there. And it's not just the performance piece. It's the ability to hook up to the cloud, to be highly available and fault tolerant, kind of all these things that you think of as enterprise grade or enterprise ready. So I got really interested in this idea, not of blockchains as crypto, but blockchains as a piece of enterprise infrastructure, if we could reimagine them the way that the cloud would have built them, right? So kind of think like if AWS had invented a blockchain, how would it have done it? It would have made it highly distributed, highly reliable, would run in the cloud, obviously, and be really easy to use. And so that was sort of the goal, right? Was reimagine blockchains with this very kind of cloud forward and kind of cloud native capability, and then let that technology go out there and start to solve some of those really interesting, challenging data sharing problems that we can chat about here.
Gotcha. Okay, very interesting. Thanks for the perspective. And so maybe another thing that we can cover at kind of a high level before we get into the details here are just defining some of the key terms here. So I'm just going to throw a few terms at you, and if you can just give me, kind of a nice common sense definition of how you think about them. So the first are blockchain and next gen blockchain. So what is a next gen blockchain? Second would be serverless infrastructure and serverless ledger. And then the third would be Web3, which is kind of a big semi-amorphous term. Can you just give us a quick summary of how, so we're all kind of on the same page with these terms?
Sure. Well, let's start with blockchains. Blockchains are, for folks who haven't worked with this before, they are in a way kind of a form of law, right? Like people are generally familiar with, on the technical side, you're usually familiar with application and system logs, these ordered lists of things that happen in some order on some system. And if you're a business type, you're used to the concept of financial or accounting ledgers, right? QuickBooks Online, right? You made a bunch of transactions, they occurred in a specific order, and you can kind of figure out if you run from top to bottom what your current balance is. Really, at the end of the day, like the implementation tech aside, that's what a blockchain is. It's an ordered list of some kind of transactions or activities that happened, and then usually at the same time you're sort of keeping a running total, as it were, right? A copy of whatever that current state is. Lots of details about how you make that happen, what the sort of the tamper-proofing and everything else that's kind of required in there, and how you make that kind of cryptographically secure. But at the end of the day, it's really just a list of things, just like a list of accounts, account changes you would get in your bank statement at the end of the month. That's a blockchain. Now, often when people talk about blockchains, they mean something a little bit more. They usually mean not just maybe a blockchain, but a distributed blockchain. And so that starts to get a little more interesting, because now you're talking about this ledger, this log, the statement of accounts that is somehow kept consistent and the same for multiple people, for different people, right? So that like you and your bank, for example, know the same information. You agree that the same set of things happen in the same order, leading to the same account balance at the end of the month. And you can see how that would be really important, right? You don't want to be in a disagreement with your bank about whether a transaction happened or not. And distributed ledgers are a really exciting idea because they let two different companies with maybe completely different IT infrastructure, completely different teams, completely different compliance regimes, maybe in completely different parts of the world, have an absolute guarantee that they know and believe the same set of data. So that's why distributed ledgers are such an interesting and potentially disruptive technology. Now, most of the world knows distributed ledgers in the form of crypto, right? Because what they get used for is to store the balance of, your cryptocurrency. So you go and buy some Bitcoin, for example, and all the Bitcoin servers everywhere in the world agree that you bought that Bitcoin, right? That you now own that, and you here is really an asymmetric public-private key, so it's a little more complicated than your identity when you go to the bank. But for the sake of our discussion here, let's assume that that's essentially how that works. But cryptocurrencies aren't the only place where distributed ledgers are useful, and we'll talk a little bit about use cases. You can imagine anything from supply chain, like you go to the store and you buy a bottle of ketchup. The bottle of ketchup maybe got moved by 3 or 4 different, had to be produced somewhere. You needed a glass bottle, you needed tomatoes, it had to be packed into a crate. The crate had to be driven somewhere. It had to eventually be loaded onto a store shelf. So everybody needed to know kind of where that ketchup was, what was happening, was there enough. That kind of shared information could be stored in a blockchain, just like a Bitcoin balance could be. And that's where some of these interesting business use cases come from. So that's kind of from blockchain to distributed ledgers. Now let's talk about kind of serverless ledgers. So one of the things that Vendia's done, which is very different from the way blockchains and distributed ledgers are normally built, is we designed it to work in the cloud. And this is where things get a little bit technical here. Most blockchains are built using a single machine, right? You can deploy Ethereum, for example, to your laptop. That's kind of useful from a testing perspective. It's also really, really bad in a lot of ways, because it means that when you hit the limits of what one machine can do, you run out of memory, you run out of CPU power, you run out of networking capacity. You therefore hit the limits of what Ethereum can do. It was designed in such a way that it can't ever do better than what one machine can accomplish. And that's really dangerous, right? No cloud service is ever built that way. Something like, when we built these things at AWS, like Lambda and API Gateway, they use, millions of machines. And so they have access to a huge amount of raw computing capacity. So that's what's different about a serverless blockchain or a serverless distributed ledger from maybe a conventional one like Hyperledger Fabric or Quorum, is that they have access to the power of the cloud, to all the many, many machines in the cloud, and they can kind of spin those machines up and then tear them back down again. And that ability to recruit, as we say, recruit silicon in the space of milliseconds and then let it go again, gives this amazing scalability, but also really, really tight cost enveloping. So it's a kind of double win. And cost enveloping is important for the people who have to buy it, obviously, but also for the planet, because lower cost also means lower carbon footprint, right? Which means fewer emissions for a given amount of computation in the underlying technology there. So that's actually gets interesting for lots of reasons to try to minimize that.
Gotcha. And then the last term there. Well, thanks. First of all, that helps me a lot actually to understand kind of the foundation here. The last would be then Web3. How do you view that? That seems like a few technologies kind of grouped together.
Yeah, it does. And so, I'm glad to kind of save this one for last, because Web3 is kind of a broad mix of concerns. One take on Web3 is that it's an attempt to actually make some of the information and the data that's out there less centralized in nature. So you often hear this term bandied around, decentralized, when associated with blockchains and especially with distributed ledgers or cryptocurrency. And the idea behind decentralized is think of it in opposition to these classic centralized systems. Today you look behind the scenes at take your favorite company like Airbnb, right? They got a bunch of machines with a bunch of data running a bunch of applications. You create an account there, or you rent a place to stay. They've got a database. They store your information. They have all your private information, all the information about your orders and where you've stayed and everything else, sitting in one of their databases. In a decentralized system, two things can happen. One is, of course, different people can share the data. So think how, like cryptocurrencies, right? Everyone shares that information about who owns which Bitcoin. But the other thing you could do with decentralization, here's where the Web3 concept gets really interesting, is remove the sense of one person being in control. Like no one person controls Bitcoin, right? Nobody gets to step in and say, well, I'm going to take your Bitcoin back, or I'm going to move it around another account. The owner of that is in control of it. And part of the idea behind Web3 was, what if you took that idea of control, not just of, say, a Bitcoin account balance, but of things like your personal information, your employment history, your reviews from former employers, who you've given permission to advertise to you, and place that control not in the hands of these large, massive companies, maybe like a Facebook or a Google, but instead pushed it back into the hands of the people who are using the internet. And so by through this decentralized technology, create a more sort of egalitarian and democratized way of controlling and delivering and using information. That's sort of the Web3 goal. I would say that the world has obviously not realized that outcome yet, but it's an interesting one to hope for, right? And then when you get down to kind of brass tacks on technologies, Web3 becomes a lot of discussion around, well, how would we get there? Like, what technologies would be needed? How would they actually work? What would be necessary to deploy them? And that's where things are still very chaotic. Right? Imagine sort of the early days of the internet before sort of all the functionality of the internet was built out, and people were still trying to figure out, what's a browser, what does the network do, what are the data exchange formats, and that's frankly where kind of Web3 is today. Still very early in that journey to a more open and decentralized and frankly kind of egalitarian notion of internet and data ownership.
Yeah, great. Well, so I want to get into use cases, but just maybe one more kind of angle on Web3 I'm personally curious about. So we have big, very large investments from Facebook, from Microsoft. I'm a happy Microsoft customer. I'm not a happy Facebook customer, but anyways, these are fine companies, right? So I have nothing in particular against these companies, but I would say that they don't strike me as caring very much about creating open infrastructure or this kind of vision, right? So it strikes me that they're trying to maximize stakeholder, shareholder value, and closed systems have traditionally suited them very well. So I'm a little bit skeptical that these investments that they make are made with the intention of the ideals that you've just kind of shared with me around Web3. Of course, there's maybe a lot of other people that do have those ideals and are trying to build solutions around them. So if I look forward 20 years, I could say, well, what if, could there be a Web3 that is dominated by Facebook and Microsoft? Is that, would that still be Web3, or would that just be them using certain technologies to create new platforms? Or, how do you look at the different possibilities? Does Web3 have to have these kind of sharing dynamics or control to the individual dynamics, or could there be a Web3 that emerges that has some of the the marketing potential and the kind of the digital twin aspects of people living in these platforms, but still being as more or less as controlled as Facebook is today by a single company?
Yeah, it's actually a fantastic question. And in your look, we talked a little bit about maybe this sort of idealized state here. The reality, of course, is going to be a blend, as it always is, right? Just like not every piece of data out there is owned by one single large centralized entity today. So 20 years from now, it's not going to be the case that all of your data is somehow fully decentralized and fully under your control either. It will always be an advantage to companies to keep information about their customers. And I don't think any of us should expect anything other than that companies would fight tooth and nail to have that to have that information removed from their control and their access. I'll give you two interesting trend lines here, though. Right, one of them is the open source movement. You roll the clock back. I started at Microsoft, oh boy, probably back in 2006, and open source was kind of a dirty term, right? It was something the company was kind of actively fighting against. There were a lot of rules about how to not use it or not allow it or not how to prevent it internally. Look today. Microsoft's one of the biggest proponents, advocates for, users of and contributors to open source software, right? Kind of a complete 180 that company has done. So I think what's happened to code there probably eventually to some degree happens to data and data ownership, but it's going to take a slightly different path, and it's a much, much broader and longer road to hoe, because a relatively small percentage of the worldwide population work on code, either producing or consuming it, whereas all of us have personal information. So I think you can see an analogy there in the code, but I think it's a much, much longer pathway to democratize that personal data. The other interesting trend line there, though, is which is being driven by by nation state laws and regulations, is around these compliance and assurance programs. So things like GDPR in Europe. There's one called CCPA in California, which was followed up by Prop 24, very GDPR-like in flavor, and they're starting to force companies to be more transparent and responsive to the information that they keep. And so that doesn't speak to the technology or where that data lives necessarily, but it starts to force things in a direction of swinging the pendulum of control a little bit back to the people about whom that data is representing, right, rather than the people who are collecting that data. And so I think you're going to continue to see a bit of a constantly escalating war there, like a constant battle of companies who want to keep that information and people who want to preserve their privacy and have more democratized access. But I think those two trend lines are going to be interesting ones to kind of follow over time.
Yeah, great. Thanks. That's a great perspective. Let's then look at the use cases. So maybe you've already given us a couple examples, but before we get into specific examples, I'm really interested in how you think through what characteristics define a use case that would be suitable for blockchain rather than for a traditional architecture. So is it the number of stakeholders or the requirements that specific stakeholders, a high variety of stakeholders can control data access, or is it how flexibility in terms of financial flows between stakeholders? What would define for you the characteristics of a suitable use case for a blockchain architecture?
Let's kind of first make a really quick distinction between what generally gets called sort of like public and private chains here. So, like, what would you use something like Ethereum for versus what would you use something like Vendia or kind of others in that space like Hyperledger Fabric or Quorum for? Public ledgers, and I've written this thing called the three-body problem about kind of how centralized, public and private blockchains can actually all work together. And I think that's actually a wonderful way to think about it, right? Like, the world is not going to throw away 50 years of IT progress and replace it all with blockchain any more than, any individual technology replaces everything that came before. And similarly, public chains have some really interesting advantages, but they also have some really interesting and challenging scale and cost. I'll just describe as challenges, right? Like that make them not suitable for everything. So public chains generally great for two things: ordering and non-repudiation, and generally that information has to be placed on them in an infrequent and often digest-based form. So think like, maybe you're like a bank, for example. You put your end of the day balance on Ethereum. What you can't do is record a million transactions a second, because Ethereum's 14 transactions a second isn't going to be able to handle that, and you're sharing that 14 TPS with everybody else on the planet. So the cost per transaction is high. The latency of a transaction is high. The system can't go any faster than it can go. And so what you typically want to do there is put kind of coarse-grained updates that become useful for sort of public dissemination, right? So think something like, the public records that I have a place in King County up in Seattle. By law, the information about who owns which property has to be made a matter of public record. Obviously, if you sell a house, it's important to know who